Welcome back to YouTube channel Chemistry Live UGPG. So today we are going to talk about carboxylic acids and its derivative, lecture 2. So this will be highly useful for BSc chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime, and help to learn others. So this is the syllabus under CC6 paper semester 3 and unit 4, that is carboxylic acid and their derivatives. So this is the prerequisite knowledge about mechanism that we have discussed last class. So where the reactant is converted to the product in the presence of the reagent. So let's again discuss what is mechanism. So mechanism shows the movement of double-headed arrow, how bonds are broken and new bonds are formed, leading to formation of product, which may be a multi-step or one-step process. So this is represented as AX bond, single line or two dot of electrons. So the bond on which atom it is heterolytically cleaved, so that atom gets both the electron with negative charge and the other atom gets positive charge. So the negatively charged species is nucleophile and positively charged species is carbocation or electrophile. And by principle, always the nucleophile will attack the electrophile, giving rise to nucleophile electrophile bond or AX bond. And we cannot attack electrophile to nucleophile, which is not possible. So next is the method of preparation of carboxylic acid, that is we take RCOH and we react that with thionyl chloride, giving rise to acid chloride, and that would react with diazomethane, giving rise to diazoketone, and in presence of silver and water you get RCH2COH. So this is known as homologation of carboxylic acid, and this reaction is known as Arndt-Estert synthesis. So while discussing the mechanism part, so this is the structure of a diazomethane, CH2 minus N2 plus. So CH2 minus act as nucleophile, it will attack to the carbonyl carbon and this CO bond will break on oxygen. So as a result you will end up with this intermediate, and here O minus will come back and it will kick out Cl as Cl minus. So here the leaving group is Cl minus. So as a result you end up with this intermediate, and again Cl minus will act as nucleophile, it will take this proton and this CH bond will break on CH. So as a result you eliminate one molecule of HCl, giving rise to this intermediate. And again what happens, this will undergo rearrangement. So here this C minus will come here and this R group will migrate to this carbon and this CN bond will break on N plus. So as a result we generate a cation, and this upon hydrolysis reacting with water giving rise to the carboxylic acid. So water act as nucleophile, it will attack to the carbonyl carbon and this CH double bond will break on CH. So as a result you get CH minus, and this CH minus will take the proton from this protonated water and this OH bond will break on O plus. So as a result we generate RCH2COH. The next reaction for preparation of carboxylic acid is a haloform reaction, or we can call it iodoform reaction. RCOCH3 would react with iodine and sodium hydroxide, so giving rise to RCOH plus CHI3, that is iodoform. So while discussing mechanism, so OH minus ion will act here nucleophile, it will take the proton here and this CH bond will break on this carbon, so you generate a carbanion CH2 minus. So this CH2 minus would react with iodine, so it will attack I and this I bond will break on I, so it will cleave this I bond giving rise to I minus. So we generate the product A, and again this A would react two times with OH minus and I2 giving rise to this product RCOCI3, and again we have in the reaction medium OH minus ion. So this OH minus ion again act as nucleophile and it will attack to this carbon and this CO bond will break on oxygen. So we end up with this intermediate. When this O minus will come back, it will kick out Ci3 as Ci3 minus. So we end up with the product carboxylic acid, and again this Ci3 minus can react with carboxylic acid, giving rise to CHI3 plus RCOO minus. So this CHI3 is known as iodophore. Next is physical properties of monocarboxylic acids. So generally aliphatic carboxylic acids except lower members, that is C1 to C4, are sparingly or insoluble in water, but soluble in less polar solvents like ether, that is due to high carbon content and reduced polarity. The next is the solubility in water of C1 to C4 lower member carboxylic acids is due to the hydrogen bonding between the carboxylic acid group and water. Two number of hydrogen bonds make stronger association, which leads to higher boiling points. So here you can see we have represented two hydrogen bonds, so it leads to a dimer. Similarly, lower aliphatic carboxylic acids C12 up to C8 have a strong irritating unpleasant odor, whereas higher aliphatic acids and aromatic acids have little odor due to their slight volatility. Electron withdrawing carbonyl group in COH group makes OH bond more polarizable. The next we need to discuss acidic character of carboxylic acids. So RCOH react with water, giving rise to RCO minus and H3O plus. So we need to write down the acid dissociation constant Ka as concentration of products by concentration of reactant. So RCO concentration into hydronium ion concentration divided by RCOH concentration. So here greater the value of H plus or H3O plus concentration, higher the value of acid dissociation constant Ka. And we know pK equal to minus log K. So a stronger acid has a smaller pK value but larger Ka value. The next is the reactions of monocarboxylic acids. So carboxylic acids react with alkali, sodium hydroxide, giving rise to sodium salt of carboxylic acid plus water. Then reaction with thionyl chloride, PCl3 or PCl5, phosphorus pentachloride. So RCOH react with all these three reagents separately, giving rise to the product acid chloride, RCOCl. Similarly, the acid would react with ammonia, giving rise to ammonium salt, and upon heating we get amide. Similarly, acid would react with alcohol, giving rise to the esters. Then acid react with acid chloride in presence of pyridine, giving rise to acid anhydride. Similarly, acid can be reduced by lithium aluminum hydride, giving rise to primary alcohol. Similarly, silver salt of carboxylic acid react with bromine and CCl4, giving rise to alkyl halide, RBr. Similarly, acid can react with Grignard reagent, RMGX, giving rise to alkanes. Then acid can react with alkyl lithium, R minus Li, giving rise to RH plus the lithium salt of carboxylic acid. Then second equivalent of lithium salt, alkyl lithium, would react with this lithium salt of carboxylic acid, giving rise to this intermediate, and this upon hydrolysis you get JMDiol, and this JMDiol will lose one molecule of water, giving rise to a ketone. So here the reaction of carboxylic acid with alkyl lithium, two equivalent, giving rise to the product ketone. Similarly, RCOH react with thionyl chloride and dialkyl cadmium. So first step we get acid chloride, and in second step we get the ketone. The next is the decarboxylation reaction. So acid sodium salt of carboxylic acids can undergo decarboxylation reaction by heating with soda lime, NaOH and calcium oxide, giving rise to alkane. Similarly, carboxylic acid undergo quatreous reaction by reacting with thionyl chloride and sodium azide, giving rise to RCON3, and which ultimately give isocyanate, which upon hydrolysis giving rise to primary amine. Similarly, carboxylic acid can undergo Hell-Vollard-Jelinski reaction, giving rise to alpha halo acid. So carboxylic acid, which has a alpha carbon, can react with red phosphorus and bromine, giving rise to alpha halo acids. So phosphorus and halogen can react with PX3 trihalide. Then RCH2COH can react with PX3, giving rise to RCH2COX. Then RCH2COX can react with the halogen molecule, giving rise to RCHX-COX, and it would react with another molecule of acid, giving rise to RCH2COX plus alpha halo acid. Please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveugpg.com. For class 11th and 12th standard, the channel is Foundation Chemistry AV. This is also available in the website www.foundationchemistryAV.com. So this is a simple step towards e-learning, making life better. Thank you all for learning.